So welcome to Linda of Green Bay, to Andrew of Aotea, to Ange of South Westland, who's had a rain day today, and kia ora koutou. I'm Douglas Walker of St Patrick's College in Wellington, and here on behalf of NZASE. So if you'd like to we might start off with just introducing yourselves and telling us a little bit about your program with 1.2 so far. Does that sound okay?
Yep.
Cool. Thank you.
Now nobody wants to start.
Take the bull by the horns, Linda.
Okay. So I'm from Green Bay, high in Auckland, on the outskirts of Auckland, and we're right on the edge of the Waitakere Ranges. We, for 1.2, the investigations, this is the second year for us, and it's changed slightly from last year, but we do a lot of investigations as part of the learning throughout the course. And it's a lot of fun. We're doing so many more practicals now, and the kids are really into it. So it's a really cool standard. So much fun.
Cool. Thanks, Linda. Andrew, would you like to step in next?
Yep. Kia ora. I'm Andrew McKenzie. I'm at Aotea College in the northern suburbs of Wellington, Porirua. And we just doing the pilot. We just started the pilot this year, where there's obviously been a few schools that did the sort of mini pilot or pilot last year. So it's our first sort of go at it, and really enjoying it. And with our 1.2 investigations, we decided to do stuff about sea levels rising, which is basically we're surrounded by the sea down there in Porirua, the sea and the bay, and so we thought that would be a really relevant area for our students to learn about. So that's us.
Thanks, Andrew. Over to you, Ange.
Kia ora. I'm Ange. I teach down at South Westland Area School on the West Coast, and it is a wet day like it usually is. 1.2 for us, we are also surrounded by the sea. We did sea level rise as well for our first topic, but like Linda, we also just do investigations throughout the year now, and we just kind of do the assessment as a collection of related practicals. So we did sea level rise, and we're about to do a reassessment with Te Whare Tapawha as our context like health for our next collection. And yeah, it is a lot of fun, bit silly at times too. So yeah, it's good.
Kia ora, Ange. Thank you. You've mentioned that there was involvement with the pilot last year, and I'm interested to know how that's changed then. What changes have happened to 1.2 from last year to this year?
Last year, where they had to alter a method to make it better, and that was a logistical nightmare for us. I mean, we've got between 300 and 400 students doing it at a time, and our technician was going to kill us. And also the kids aren't really prepared for changing a method. They don't know what to look for. And they could kind of do it for a fair test with some degree of success. But when it comes to changing a method for pattern seeking and model making and observing, you can't do it. So that's why there were changes made on last year's standard.
Yeah, they definitely seem to change focus from having the kids alter the method and make it their own to emphasising that collaboration between students, right? Having that wānanga, that discussion and building ideas together. That's what I noticed.
I think they also have changed the focus to what have you learned from this investigation, and is this investigation answering your question? So it's less about the method and more about the learning.
Andrew, have you had any thoughts since with the changes that you've seen this year?
Well, I only joined this year, so I didn't really know about the stuff from last year, really. But I agree. I mean, I did kind of have a quick look at it the stuff that they had last year. And yeah, I agree that it seems to have really progressed this year into the fact that it's more about them seeing whether the investigations that they've done are valid and actually answer the question that is at the top, rather than just basically doing an experiment just for the sake of it. So a lot more thought from the students about whether that investigation that they just did was actually answering the main question. Yeah.
Could you talk a little bit about the how much freedom you've had with the contexts for your investigations and how you've reached the decision that you've made to go with this year?
Well, with the pilot, we were told that last year we had a lot of freedom. It was great. We had a lot of fun. This year we were asked to do one of the 3 examples. So I guess that so that they could get exemplars up online for next year, which has sort of restricted us a bit. But in the future, it's going to be back to freedom to do it in the context that you're studying. So, and that's so much better.
Yeah, I found it a little bit of a challenge to take the context we were given, but once you get your head around, like, okay, I have to use these tasks, there is some freedom within that to pursue your own questions with your students, what actually interests them. And so like with the Te Whare Tapawhā one, we're going to be investigating aspects of health that matter to my kids. So that's quite nice. They will get to ask a question that they care about and then answer that question, hopefully. Or not. I'll be like, it was a crap experiment. Did not answer my question.
Yeah, I think they offered up 3 different kind of tasks for assessment this year, and it seems that most people have gone for the sea levels rising one because it just looked like there was a lot more type investigation type stuff you could do with that particular one. Yeah, Te Whare Tapawhā was there, and I think the other one was about seafood and catching. I don't think anybody's actually done it, which is why we haven't probably discussed that one. But yeah, it was something to do with catching seafood and the difference, I think, in population of different sea creatures at different parts of the coast and things like that, and maybe the difference over the years of the the population. But yeah, I mean, I think there was a good little choice there, and within each investigation or in each area, you could basically do anything you wanted. You could make up, I think we only made up about 10 different investigations for the sea levels rising, but you could make up a lot more than that. So, it's quite a big range that you could actually, do. Yeah.
Yeah. And how do...
Sorry. I'm trying to find the where is it?
Good on you, Linda. How do you, there's a list of investigation options, I suppose, in the standard. How have you decided on which types of investigations to use, or have your students decided that?
It depends on the question you're asking, I should say. It really does. I mean, that's what the standard's all about. It depends on the question you're asking as to what investigations you do.
Yeah, it's kind of doing the merit part first, because you're asking the students, well, what type of investigation will suit this question? And by them figuring that out, they're working towards that merit point already by like thinking about how well will this type of investigation answer my question. So I definitely posed it to my kids, like, question, cool, that's a good question. How can we answer it? What type of investigation would work? And then we went from there.
Yeah, we did quite a few investigations, and the actual assessment is geared towards the students choosing a selection of those that they thought answered particular parts of the overall context, sea levels rising, and how and they're basically judged on how well they thought that type of investigation would answer that question, rather than the results that they actually got. It didn't really matter if they got terrible results. It was all about them kind of analysing it and evaluating it afterwards to see whether that type of investigation is worthy of doing for that particular question. So it's just getting them to question stuff all the time.
In terms of workload, we're looking at a 5-credit standard, and I think there's probably been comparisons made to the 1.1s, certainly in terms of the exclusion list. What's your perception of the workload involved for teachers and students compared to, say, one of the physics, chem or bio 1.1s?
The student workload, because the investigations are part of the learning and a lot of it's done in class time, the workload's not any greater for the students. For us, the workload for the technicians greater because we're doing more of them. And for us, we're not marking everyone. You can tell when it's going to be a good one and whether it's usable or not pretty quickly. Like at the moment, when half of them are away, we're not going to use that one.
Yeah, I'm finding them quite comparable in terms of effort from both students and myself. It's just different. I think with the 1.1s, it was a lot more, it's on the students, and there was a lot of writing about them, like they had to write out their method, and just a lot of like data recording in tables or Excel sheets. This one feels a little bit more back and forth, like I'm doing a lot of questioning and then answering, whether that's writing or recording themselves verbally. But it feels about the same.
Yeah, I wouldn't say it's any more than the old standard, but yeah, it's more about, I think with the old standard you could almost mess up your results and kind of get a poor grade, where with this one you can mess up a few times and actually still come out with an excellence. It's all about your analysis of all of the stuff that you've done.
Yeah, and if I pick up on what you're saying, Linda, presumably there's an opportunity, if you've identified that an investigation isn't going to be one of the ones that the students carry forwards to be assessed on, then you can give a lot more formative feedback there.
Oh, absolutely, a lot more formative feedback, and the focus is more on the learning of the science ideas and answering questions than it is on whether you've actually decided or worked out what the dependent variable is and what the parameters are and all that sort of stuff. So I think there's a lot more learning in it. So the workload that's there is a positive workload instead of just hitting them with a stick. No, you haven't got the right dependent variable.
How have you approached the scaffolding that you've been able to provide for students? So in 3 very different schools, presumably 3 different approaches.
I guess for scaffolding, we've just been doing lots of investigations. We do the investigations mostly before the learning, so that the investigation is the learning as much as we possibly can. I mean, that doesn't work for everything, but the investigation is the learning, and then you do the one after the validity, the comparing to bodies of knowledge afterwards. So just lots and lots of, because we do it in every context that we do. We're doing investigations all the time now.
I think small school approach here. Guidance wise, or the scaffolding, because the emphasis is not on them designing the experiments so much, like you're able to really help them with that and guide them and offer suggestions, like, why don't you think about testing it like this or doing this other thing over here? You could even just give them a written method that they can follow, and they can develop it or do whatever they like. But for me, scaffolding, I automatically think of, I give them a Google Doc worksheet box thing to fill out, and my kids will either fill it out by writing, or they'll record themselves talking through what they're doing and then submit a video clip as part of that. So I try to scaffold them by laying it out step by step. What's your question? What type of investigation is this? Where's your evidence that you actually carried out the investigation? What's the answer? Just every single checkpoint for achieve merit and excellence, I've got a little box for, and they have to put evidence in that box.
Yeah, scaffolding wise, I think Linda's mentioned it in a previous meeting that we've had, is we do so many of these investigations that the first couple are kind of not that well done, and then by the time they get to the sort of 4th, 5th, 6th one, there's suddenly a real improvement in the way that they're carrying the actual practical side out, or the research out for that particular type of investigation. So I think it's just an ongoing kind of scaffolding by just saturating them with investigation after investigation, really. And it seems to work, yeah.
Consistency in what you're giving them to work with too. Like, you always have the same scientific method in the same way, and keeping that consistent with the same or similar questions coming through in the discussion and conclusion. Keeping it consistent. The kids then know what to expect and what to put in those places. So.
On that note of seeing the students' performance improve throughout the year, have the students had much of a chance to reflect on their learning, and what sorts of insights have they shared with you?
By doing when they're doing the final 1.2, they all of a sudden realise how good they are, which is, I can do this. It's great. So yeah, they acknowledge that they've learnt a lot, and also they don't realise what science ideas they learn through the investigation, because it's just there and they can answer the questions, and then they realise they've answered the questions, and it's incidental learning, and they remember it.
Yeah, I've had some really cute moments with my kids this year where they've had that, like, I can do this moment. Just like these guys are saying, the more that they have practiced with this, the more confident they feel, and then suddenly they're viewing themselves as scientists. Like, I can carry out investigations. I can talk about how I know something based on me carrying out an investigation. It's good. They notice their own improvement, which is nice.
Yeah, I noticed the same thing. Just constant improvement, and sort of sparkle in the eyes after the first few of doing the investigations, and just not having that. With the old standard, if you are part of a group and you're not quite doing the practical work because you feel that you're not the practical person, there's sort of no getting away with it with this new 1.2, because we do them almost every lesson or every other lesson. You're going to be doing the practical work at some point, and just that that student who doesn't feel that they're practical eventually does feel that they are, because we do so many of them.
So some of the low level students, the more interesting ones, they love it because it's something they can get their teeth into, and they all of a sudden understand what's going on a bit better. So it's really good for them.
Logistically, just picking up on some of the things that you're talking about, presumably you've moved away from the idea of kind of teaching this standard as a standalone, and you are interspersing those experiments throughout other topics. Could you talk about how you've done that?
Well, it's easy because it's your teaching. It's how they learn the science ideas. So it's the way it's done. I mean, they investigate, they ask questions and answer them with guidance. But it's just it just falls out of every topic that you do.
Yeah. So it's a very conscious effort on your part to set it up that way, or has it kind of evolved over the pilots?
It was a conscious effort by us because we wanted to change our mindset from the kids, us knowing the information, the kids learning the information by rote, and then going and doing that investigation half-heartedly, because why are they doing it? There's no reason. Whereas here, if they don't do the investigation, they don't actually understand or answer the question, and if they don't answer the question, then they're not learning anything. There's a reason to do the investigation.
Yeah, I approach it slightly differently. Some units I'll have investigation practice sprinkled throughout, kind of like what Andrew was saying, like almost once every day or every second day. And then other units I'll kind of have a series of questions saved up at the end that we'll investigate together, and that's where I pull out the assessment, is when I can get those questions together and just have a couple of weeks of just straight practicals to answer those questions that we gathered during the learning of a different aspect of that unit. So, but yeah, conscious decision and how you plan it, where you put the investigation practice and the assessment, I think, but definitely not as a standalone investigations unit. It doesn't work anymore, not for the standard anyway.
Okay, we did a standalone unit. We, being our first run at it, we did make a conscious decision that we would it would be easier for us to run a standalone unit. But of course, I think the expectation is that over time, as this evolves, that it will be you can pick sort of do any of these investigations throughout the year, and then it will contribute to the 1.2. But we decided to do a kind of topic on energy, fuels and heat, and with the main context of being sea levels rising, of course. And it just aimed itself at doing lots of practical work, and then obviously some official investigations throughout. But yeah, we did go the way of the standalone unit, but it did still work very well for us.
Your unit was sea level rise. It wasn't investigations. You still changed it up.
With the other, because you've had to include all of the standards, all of the NOS standards in your program this year. Where have you seen very strong links between the investigative approaches of this standard and the concepts in the other standards?
The socio-scientific, we have it because our socio-scientific is to do with pest control in the Waitakere Ranges, and we didn't really want our kids playing around with 1080 or any of those sorts of things, or killing cats, or walking through the bush and kauri dieback. So yeah, we had that separate. But because the investigations are throughout pretty well all the other units of work, the context, and so is validity, and so is features of science, they're all kind of all mixed in together.
Yeah, I'm just about to do my reassessment for this immediately following 1.4, the validity one, the maramatanga. And it's quite nice because we've just been critiquing a whole bunch of claims, practicing, noticing red flags and poor scientific investigations, and now they're going to go do scientific investigations again. So that'll be nice for them. But I also think it aligns really nicely with the socio-scientific one, maybe beforehand, like ask some questions, do some of your own investigations, and then carrying it on into our real world socio-scientific issue. It'd be super cool if you could find the link to 1.3 and find some like good New Zealand science to tie it to. Like, why not role play a bit and be some of those scientists doing those investigations that got them so famous? And links to everything.
Yeah, there's good opportunity really for involving 1.2 in the 1.1 socio-scientific one, especially. We did drugs in sport as our 1.1 socio-scientific issue. And, we did lots of practical work and to do with sport and not so much the drugs. And you can include lots of practical investigations into those 1.1s and actually have that as a backup, really. We could have easily included the Tafada Tapafa 1.2 unit. We could have done it alongside 1.1, but we decided, obviously, well ahead of schedule, that we were going to do sea levels rising, so we went down that path.
Could you give us an example of maybe one or two of the investigations that you've used? So that, with modelling, fair testing, what have you found are some really good investigations to highlight or to use for each of those different investigative approaches?
Of course, there's so many.
If you just went with one, Linda.
Modeling's a really cool one because it is quite a range of types of modelling. So we've used computer models, the one with the rabbits and the wolves when we were looking at population variation and stuff.
That's a FET simulation, isn't it?
No, that's not I don't think it is a FET. Yeah, so we've used a lot of FET. We've used FET models all over the place, which is pretty cool because then you've got computer models, and then we've also done other sorts of models like the sea level rise one where you put the ice in the water and the water level doesn't go up, so it's not so much the sea ice, that sort of stuff. So there's just so many options and so many places it can go. It's too many.
I'm a fan of exploring and observing in video format, where the kids have to go look at something. So it could be, we used stream next to our school, glaciers, coastal erosion, at a local beach, but having the kids filming themselves, exploring the area and making those observations as they notice them, like, oh, look at this cliff and the way it's curved, and oh, look how tall that glacier is, and look at the colours in here, and just trying to get into practice using their scientific terminology in those observations. But I definitely really rate just giving them a camera or a recording device and having them record their observations that way about whatever you want.
Yeah, just a few of the selection that we did. We did some particular pattern seeking stuff about Wellington sea rises over the last so many years. They were given some data to plot and to extrapolate into the future, and just to discuss what effect this could have on the particular coastline in Wellington, especially at that particular time. In the future, sorry. Different substances that make ice melt. The students knew that ice melts faster with salt, but the amount of students I had telling me, well, that there's loads of salt in the sea. So we had discussion about, will that affect, will that accelerate then the ice melting? So just discussion after discussion, classifying and identifying greenhouse gases, the main greenhouse gases that could cause problems in the atmosphere, and how we could solve those problems. Take a Kaitiakitanga approach to how we lead our lives and how to reduce greenhouse gases personally, and what can corporate businesses do to reduce their kind of outputs. So lots of kind of spin-off stuff from just a plain old experiment, but then the discussion afterwards was pretty good.
There's some really cool ideas there. Thank you for sharing. The FET simulations were mentioned. Are there any other places that you found really useful in terms of getting resources to support the teaching and learning of this standard?
Science Learning Hub's great. Yeah, that's a really good starting place for anything. And then it's just, searching.
Local organisations. Our local doc's pretty good. Just call up, ask a question if you've got something conservation related. They're fantastic. But kind of like a who you know situation, right?
Mm.
Yeah, Science Learning Hub, we use a lot of their stuff. There are at least 10 or 12 different types of investigations for sea levels rising, so it's a very easy one for us to pick up some of those and adapt them for our use. And just thoughts and ideas that get thrown around the table. As we've all got ideas, so it's just been a mixture of those, really.
In the standard, the phrase taiao context is used. Can you explain what your understanding of that is now that you've engaged with this work?
Just it's local. It is a local curriculum. It's a local area thing. You do what works for your local area and your kids, and that's basically what the taiao is, I think.
Yeah, I kind of went our environment, and sometimes that means all of New Zealand. We're talking about a countrywide environmental thing. Sometimes we're talking about literally on the school's environment, stream right there. Sometimes we're talking about their home environment. Sometimes we're talking about inside their body, their microbiome. Just, everything.
Yeah, we did a lot of local stuff, but obviously the relevance of sea levels rising is a worldwide kind of issue, and we have a good percentage of Pacifica students at our school. And when we started to look into sea levels rising in the immediate area in Wellington or Porirua, we then talked about some of the Pacific islands, and obviously some of the Pacific islands that they are specifically linked to, and they found that really interesting to actually get a map of the island of their choice and go through what could happen to those islands if the sea levels rose by 50 centimetres, a metre, 2 metres, and so on and so on. And just the stories and the discussion afterwards was just fantastic. So just that local thing definitely, but relevant to the students that are there, but that wider appreciation of the planet, and we're all sort of part of that, playing our part. So it was really good.
Thank you for sharing. The other, I suppose, the difference in the excellence requirements there, and some of you mentioned earlier, the wānanga. How have you approached that aspect of the teaching and learning?
It's been pretty cool, actually. We've done a bit of stuff where, the old experiments, and you check what you found against other people in the class or class results or stuff like that. And if yours are different, then you check it against some of the others. And if yours are the ones that are different to everybody else, you go back and think about why that might be. Then there's the body of knowledge part of it, where you go and have a look at some science knowledge, or you compare yours to some scientist's experiment and see whether your results match, and how valid your results are against what is already known, and what have you found out? Have you found out something new?
Yeah, I think the wānanga bit is quite easy to embed into the teaching, the learning, the doing of the standard. Particularly if you have group work going on, then the kids are talking to each other about how to carry out the experiment. They're talking about the experiment as they're doing it. If they notice something's going wrong as they do it, they can tweak their method or start over. They're talking to you as the teacher about what's going on. You can kind of share your knowledge back to them. The hardest part I found was capturing evidence of that wānanga, of that discussion. Hopefully I've got it down now, but we'll see. But I think it's natural, and it ties in really nicely with that validity standard, because they've just been critiquing other people's scientific endeavours, and now it's their turn. Critique yourself.
That's confirmation from kind of well-known scientists across the planet on the internet with their own results is a real good thumbs up for the kids. But yeah, I mean, the real bonus that I saw was that we've got a couple of students who are quite reclusive and quite, a bit of a loners really, and just to see, that they had to kind of discuss their results with another group, with other students, because that was part of the assessment. I watched a few of those discussions and they were just magical, sort of getting them to kind of talk and discuss about what they'd done, the different investigations that they were going to select going forward, and comparing each other's results and talking about the results and seeing if they were the same. And just those discussions were, not really, when they wrote them up afterwards, it wouldn't kind of reflect the magic of the conversation. But yeah, it was still there. So yeah, it was good.
Just coming back to your earlier point there, Ange, I felt that there was a little bit more you're about to say about how you think you've got the capturing the wānanga. Can you talk to us a little bit more about how you think you've got there, or what you've learned?
Just in that scaffolding, I mentioned I'm a fan of Google Docs and boxes, and my latest box says, who have you discussed your investigation with? And I'm hoping that there will be a variety of people there. And then, how did this discussion influence your understanding of the current assessment, Te Whare Tapawha? So I'm hoping that will get them to acknowledge who they're talking to about their investigation, what they're talking about, and hopefully they're going to be able to make that link. But it's a bit of a work in progress, right? I think the thing is that they do this naturally, and unless you have a camera in their face all the time, they're not particularly good at noticing when they collaborate or compare their results with other people. That's something my kids at least struggle with. So hopefully I've got it.
Well done. What challenges have you encountered as you've been going through these trials, or these pilots rather?
For this investigation last year, it was that developing a method that was hell. This year it's so much better, and it's really coming together this year. The challenge is time, really, and because it's over an extended period of time, absences are a challenge. So, which is why when we don't have to do that particular one, having a range over the year, it means that if kids are away for one, they'll be there for another one. It'll be fine.
Yeah, I just talked about probably my biggest challenge. But I think first and foremost, it's making sure that they have a good question and good investigation to start with. I'm not sure I recommend letting every kid come up with their own question and investigation like I did first time around. But making sure that they're set up on the right path to begin with, and then just capturing all the good stuff they're doing. Like Andrew said, all these magical moments. I'm just figuring out how is best to capture that without doing it for them, because part of this standard is about them knowing the value of that collaboration and those magical moments. So setting them up to find success without doing it for them is just my challenge.
Yeah, I think it's just that time factor. If you decide to become a pilot school next year, then, my number one piece of advice there is get together as soon as possible with your kind of department, give roles to who's doing what and who's developing what. And, we've struggled through only having two of us doing the science course. We've got the Chem Bio on the go as well. We've got five classes and 5 teachers doing that, and 3 Earth, Space and physics classes. So there's only 2 of us kind of trying to keep all this science stuff going. And so it's difficult, when there's only 2 heads to bang against each other and to find that time to sit down and develop stuff. So, time as always, of course.
And you mentioned first time round there. Have you had some experience with reassessments using the new standards?
That's my whole jam for this year. I'm trying to do a reassessment or further assessment opportunity, to use the correct language, for both of these internals. As I used to be one of those teachers that would cram in every available internal into my level 1 course, I still want to provide as many opportunities for my kids to get those credits as possible. So so far I'm on track, doing my reassessment for 1.2 next week.
Very good. What advice would you give to other schools who, were, as Andrew mentioned, sort of thinking about being a pilot next year, or about using these standards beyond then?
Think outside the square. Don't go with the same old things that you've been doing. Think about how you're actually wanting the kids to learn, because learning is very different with these standards. It's the actual skills that come first, and the actual science knowledge comes out of those skills, and be prepared to allow it to do it. And this standard is one of those standards that really does allow the science ideas to come out of the investigations for them, as long as you choose the right method and stuff like that. But,
Yeah, I think I approach these new standards as thinking, what do I want my science students to potentially leave school with? Because a lot of kids in the country don't carry on with science to the level 2 and 3. So just what do I want them to leave school having a better understanding of, and trying to emphasise that place-based learning, not doing these standards for the sake of doing these standards to give them credits, but actually what are they going to learn that a functioning adult needs to know, and going from there, making them care, giving them a reason to care about what we're learning is good.
Yeah, my advice really would be just to kind of make as many connections as you can, especially with the the pilot schools that have been doing it either last year and this year, because we have developed some resources that can easily be adapted for your school, your area, so don't feel that you've got all this stuff to plan and all this stuff to kind of sit down and spend days and weeks of planning. Some stuff has already been done, so don't panic. Just use the resources that should be there. Yeah.
Ka pai. Thank you all very much for sharing. We've got a little bit of time now. Catherine, do you have any questions that have come through for our pilot schools?
Yes, I do. So the first question is, how many do you have in each group when carrying out an investigation?
depends on the investigation.
Fair point.
Yeah, some you can have, you can work in pairs, some you can work in 4s, some you can work in 6s, or it depends what you're doing.
Yeah, I've had anywhere from individuals up to groups of 6.
Yeah, definitely some can be done individually, which is always great. I think our biggest group was probably 3, just because of the makeup of the class. But yeah, it's open to interpretation. Yeah.
Cool. Thank you. And the second question is your assessment via portfolio or one final investigation under test conditions?
Portfolio is the way to go for this one, because you don't always do the investigations back to back. Sometimes you do an investigation and answer a question, and then you do some more thinking around it, and then you ask another question. So portfolio is the way to go for this one.
Yeah, I did a portfolio, but with back-to-back experiments. Not enough time for thinking. But certainly not under test conditions. It's just not, I don't see their relevance to when they leave school. They're always going to be able to Google things in this day and age. So incorporating that into the planning is pretty important.
Yeah, just a kind of little portfolio. We did quite a few investigations, and it was up to them to select the ones that they thought were kind of more relevant to them to move forward. Yeah.
The responses to this they're not Googleable responses. You can't Google the answer. It's not going to give it to you. You actually have to put the answer together yourself. So
that's great. Thank you.
It's pretty hard to cheat on that as well. I'd just like to add that in. Like they could copy each other, but that's about it.
Yeah. This question is actually from me because I'm a bit of a science fair geek. And typically with senior students, we struggle to get entries because they say they're too busy and they're bogged down with NCEA. So do you think that this standard will actually open opportunities for students to enter science fair? Because while they are investigating within your context, they still have flexibility to come up with their own investigation.
That would depend on time, I would think, more than anything in the course. But you could build it in. I don't see why not.
Yeah, I think the emphasis on them coming up with the questions could lead itself to more of that science fair things.
Yeah, definitely. Yeah.
Okay. And have you had a lot of input from the mana whenua?
We don't have one. We do, but they're very, very small and they're just starting out. I mean, we're in the middle of the city. Yeah, they're not in a space to help us very much at the moment, but we are developing it as a school. But just the nitty gritty stuff for us, it just isn't there yet. They can't cope yet. It will come.
Yeah, we are over an hour away in either direction to our nearest marae, which does make that a bit tricky. But similar position, our local mana whenua, they're not in a particularly great position to spend their time helping us right now. I'm getting more input from families of the students involved, which is quite nice. But we're putting feelers out, starting to build those relationships, come back in a few years. Maybe I'll have a better answer.
I think some schools have very strong existing connections, and I've heard stories about how they've been drawing on those. But I think for others, it's still early days in terms of building up relationships with local iwi.
Yeah, we've got pretty good relationships, but we've been doing quite a few pilot subjects this year. And so a few other subjects were chosen to, go out for the day and discover some more stuff and have a day spent with iwi. And we haven't in science had that opportunity yet, but I know it's coming towards the end of the year, so we're just waiting our turn.
Cool. We've got a question. It was, what about being more inclusive of Mātauranga Māori and also the treaty? So it says we need to be teaching science through a bicultural lens. So how does this investigation sort of lend itself to that?
Once again, it's the values that the investigation's trying to put forward, that it's valuing all types of investigations, observing and exploring right through. And also you've got it on putting in the local context for us, the taiao, and also wānanga, and that's huge in this investigation.
Yeah, I think it comes down to us role modelling, seeing value in Te Ao Māori and Mātauranga Māori and how that ties in. And certainly it's helpful to have those little smatterings of te reo all throughout the standard, because we have to use them then. Even if we butcher them to start with, you say them so much, you get a little bit better each time, and then the kids have to use them, and you're just demonstrating that these words, these values, these ideas, this language is valuable and should be treated as such. Te whare tapawha is obviously a really nice way to bring in some of that Mātauranga Māori, especially for kids who've got a great health teacher and know about whole order and those other models of health. But it's tricky and it's a journey, but it's definitely easier to incorporate Mātauranga Māori with these new standards than it was with the old ones, where there's not even a mention of it, right? So.
Cool.
Yeah, I'll just repeat. It's just about the values, really, of looking at sea levels rising affects everybody, and just having those values and how it affects, a lot of Pacific nations, and having respect and empathy, and all those values that we're trying to get across is for all, really.
Great, thank you. And we've got one more question. It's going back to the portfolios. So I was just wondering if portfolios can be assessed paper or digital, or a combination of both.
Well, in the pilot, they want everything digital. So we're just doing digital. But I don't know, I have a look at the conditions of assessment. It doesn't say anything about whether it's digital or not.
We're submitting them all digitally, so whether the kids do them in paper and then we just turn it into a digital file.
I suppose with the number of investigations you're potentially dealing with and at different times of the year, it might be quite hard to manage if you were using paper copies.
They don't want the whole investigation put in. There's a template on the website where they just have to, for achieved, they have to show that they've carried out the investigation, that they've collected data and findings, and they've reported findings on the investigation, and then that can be put onto a template. They don't actually want the whole investigation put forward.
As you've been going through this work, I imagine you've had some thoughts about how you might adjust junior programs. Could you talk to us a little bit about what your thoughts might be in that space?
We've got to actually, instead of just having a practical at the end of the learning, you've got to make the practical more involved in the learning. Also, you need to be very, very explicit about what type of investigation you're doing and why you're doing that type of investigation. And you need to start that early so that they get used to it. And it also allows you to put more value on observing, exploring, pattern seeking, all those other things that have never been seen as a practical in the past, because you're not blowing anything up.
Yeah, I just find in my junior science now just bringing in those keywords and phrases and practicing more diverse practicals and naming them as such. So, when we're going to go look at stuff, it's exploring and observing. When we're using a classification key, it's identifying and classifying, just naming it so that they're more familiar with those terms coming into level 1.
Yeah, we revamped our Year 10 course last year in kind of preparation for them going into Year 11 this year. So, we concentrated on some of the socio-scientific issues that we thought the kids would find relevant. So to get them practicing how to write little reports and to practice validity and reliability and things like that. So, we've got a topic to do with lots of stuff to do with investigations as well. So we kind of try to mirror the whole thing, but in a junior way, and obviously not trying to repeat anything that we knew we were going to do this year. So, we had a big revamp last year of our Year 10. We're looking at starting it in Year 9 as well, having, the beginnings of it all. But that's still in the talking stage, really. Yeah.
If you ended up having some good investigations with juniors, and you felt that evidence was appropriate for level 1, would you be able to use that?
I don't see why not, if they were able to get to excellence. And the thing for excellence, though, is that it's quite high level thinking for a kid.
Once we're out of the pilots, maybe.
Yeah.
Yeah, I'm not sure actually, because obviously if we're doing specifically sea levels rising, we're not kind of doing those investigations in previous years because we want to keep it special for year 11. We don't want the students to get bored with it. So I'm not sure if, I suppose they could if it was under one of the other units, that we put one of those like Tefara Tapafa, some kind of unit in year 10 to do with that, and they would gain evidence throughout year 10 for that, and there's no reason why they couldn't produce a report on those investigations at some point in year 11. Yeah, I suppose it could be done. Yeah.
Thank you. Catherine, any last comments from the chat?
Yeah, there's last 2 questions. It says, did you deliberately set the students up with the chem, biophysics, and earth and space science? So I'm guessing 4 different investigations. Yeah, so that's one of the questions. And then the last one is, would these 4 aspects of science need to be discrete?
We've got everything mixed in together in our general science course. We've got a bit of bio, a bit of physics, a bit of chemistry in our first unit, because it's all about me and my body and looking at energy and energy transfers and energy and chemical bonds. And so it all kind of just merges together. Not so much in our local area one, but yeah.
Yeah, in my planning, I definitely started with discrete units for those 4 aspects, just to make sure I hit them all. But then the further you get into planning, the more you realise there's potential for that like bleeding in together and that cross-curricular stuff to come up. So they may have started as discrete, separate science subjects, but they end up becoming a bit more real world. You know, you find yourself speaking chemistry stuff when you're teaching physics and bio stuff when you're teaching chemistry, and you just go with it because that's how it is.
Yeah, I thought they might be more discrete, but when we started doing the drugs in sport thing, we were doing biology one day, to do with the movement of muscles, and the next lesson was to do with, the biomechanics and, some physics kind of laws about speed and things like that. And then the next lesson, we're talking about nutrition and, and some of the chemicals in the drugs that people were using. So it's became a real kind of mix really in the end, but an enjoyable mix.
Very good. That's us nearly at time. I just want to say a massive thank you. I really take my hat off to you guys who have been involved in the pilots this year, and indeed those of you who were involved last year as well. I think it's been a massive commitment, and I'm really grateful for the insights that you have had and that you've been so willing to share. So I think on behalf of science educators across the country, thank you very much, and we look forward to catching up in the not too distant future for the remaining 2 standards, 1.3 and 1.4. So thank you, Andrew, Ange, Linda, and Catherine, and to all of the people who've been watching and putting questions in. It's really useful to have this chance for korero and for sharing of ideas. Ka pai. Have a good night.